Hello, everyone. Thank you for joining us here today for another episode of the Amazing Podcast. We talk about all things Kubernetes, cloud native, DevOps, and we try to get in depth. We try to take these conversations deep with whatever topic we're talking about. I'm Dwayne Taylor, editor at Amazing. And if you like what you hear here, I want to encourage you to visit our website, amazic.com, amazic.com. You can also look for us on YouTube to find this podcast and subscribe, or Spotify, or wherever else you listen to podcasts. You can find us there. So definitely subscribe and stay up to date on what's happening here with the Amazing Podcast. Today's topic is VPC networking. And so we are going to be talking about private cloud networks. And I have with me Alex Saroyan, who is the CEO and co-founder of Netris. And Netris is one of the innovative companies in the space of private cloud networking. So it's great to have you with us, Alex. How are you doing?
Hi, Dwayne. Thank you so much for having me. Doing well. How about you? It's great to be on this podcast.
Yeah, not too bad. I'm all right too. And I was wondering if you could tell us a bit about yourself to get us started. Who are you? What have you done before founding Netris?
So I was in tech since like kindergarten, and then I became network engineer and kind of a little bit of a mix of a network engineer and a little bit of a development. And I've been designing, managing large-scale data center networks for about 20 years, right after I entered college. And that's how I got my start. And then over time, I got this idea of Netris, and myself with a couple of my good friends and former colleagues that we worked together, we've started Netris. That goes well so far.
All right. So you've always been into networking, laser focused. All right.
I love networking, building networks, designing large scale, multi-country carrier networks, data center networks for all kinds of companies.
How old is Netris? And would you say there was one particular point where there was the spark, but the seed idea to start Netris? Could you tell us about the origins?
So being on network engineering side and like engineering, designing infrastructures using traditional network engineering technologies like from Cisco, from Juniper, using CLIs, using some automation aspects, using Python to write scripts, Ansible, Salt, all these automation tools. I was kind of seeing the trend that kind of public cloud was picking up, and public cloud had totally different model compared to traditional data center, where in traditional data center, you would have a group that is responsible for applications and maybe even a huge group that's responsible for like designing, managing, operating the infrastructure aspect of it. Versus in public cloud, the ratio is very different. Public cloud kind of gives you the self-service model where every developers, DevOps engineers, they kind of consume the infrastructure in a self-service model. So like instead of going to network engineering team and requesting them to create a new VLAN or new isolation or get a bunch of new IP addresses and waiting a couple weeks to get that developed, instead of get that configured, instead of doing that request and waiting, in public cloud, they just go to web console or they use infrastructure as a code or APIs, and they self-service. So they get things done immediately. Now, immediately versus waiting a couple weeks because it's done by humans, that is not fitting global scheme of the grand scheme of things, because the amount of infrastructure is growing incredibly fast, and we're not really producing that many network engineers. So there's a gap between size of infrastructure and the amount of network infrastructure specialists that we produce. So that gap needs to be addressed. That was the idea for Netris, and we saw that cloud is kind of the ultimate, like the new way of operating the infrastructure, and we were like, why don't we build a software that will help every company out there to take this highly efficient cloud operational model and replicate in their own data centers, in their co-location, with their bare metal, at the edge, in their office, literally everywhere, to give every company in the world the opportunity to take benefit of operating infrastructure, any size infrastructure, small to large infrastructure, with the same operational benefits as hyperscalers do. That was the idea. We've been working on that, and we're excited for seeing, our vision being executed and benefited from by many amazing companies.
Wow, that's a great backstory to kind of get our conversation started. How old is Netris, by the way?
We're 4.5 years.
All right, just before the pandemic. All right.
Yeah.
If you could define the term, the key term that we're talking about today, VPC. What is a VPC, and which kind of companies need it and use it most?
So the term itself came from AWS, and but many other products and cloud providers kind of picked the term, and term is somewhat becoming standard. So although the acronym stands for Virtual Private Cloud, it is pretty much related to networking, because networking is foundation of any infrastructure, and the isolation is on the networking level. The networking functions, your subnets, your IP addresses, your subnets, your gateways, your load balancers, your DHCP. These are all networking functions that are typically part of VPC functionality. So this is how we define the VPC, and the term doesn't exist beyond public cloud as much. So oftentimes we describe Netris as saying, hey, Netris is just like a VPC networking software that is running under the hood of public cloud, but for everyone else.
All right. Yeah, that's a great definition. Seems like, you're talking about how public cloud has made it so easy to set up networking in the cloud. And seems like data center and traditional networking has really fallen behind, and there's this gap between the two. It's quite bold that, and smart that you kind of made this move to close that gap. But there's also been conversation about software-defined networking, for a long time, like more than a decade, I guess. Organizations have moved from hardware to software-based networking. How is that different from what you describe as networking today, modern networking? What has happened after software-defined networking, or what was the drawbacks of software-defined networking?
Yeah, that's a good question. And when I was engineer, even before founding Netris, software-defined networking was a kind of a thing back then, and I had the opportunity to experience and learn and software-defined networking. So that technology was designed with the network engineers being the target user, being the user persona. So it is specifically designed for network engineers with a lot of programmability capabilities. Now, this is falling short twofold. So one thing is that it is not addressing the concerns of DevOps engineers, of server guys, of application guys, because they don't understand it. This is hardcore network engineering. Network engineers understand it, but for network engineers, SDN would require additional learning. There was a learning curve, and also SDN would bring a lot of programmability component. And it's not like network engineers. Well, most network engineers are not necessarily skilled in programming, so they would need to learn a little bit of a new concepts in networking, SDN, and a little bit of programming. So this was learning curve and not really, not really facilitating how application guys and network guys work together. So that's it. We've also have seen intent-based networking, like the next generation after software-defined networking. And I think, again, the same problem with the intent-based networking. Of course, it is like one step forward. It's one step easier. But again, most intent-based networking platforms are designed having network, like hardcore low-level network engineers as their target audience. So their user interface is not designed for DevOps engineer or Kubernetes administrator to walk in and self-service. Versus VPC as a construct is specifically designed to address both concerns. So DevOps engineers, Kubernetes administrators, application guys, Linux guys, they all can go do things with the VPC without knocking the door of network engineers every time. And at the same time, network engineers, which in the case of AWS, they exist kind of behind the scenes working for AWS, right? Someone is taking care of that networking hardware and connections. But these people, they are operating one of the largest networks in the world. So VPC also gives them the flexibility and scalability and right tools to perform on that scale. Now, imagine taking VPC to a regular organization. It is literally turning network engineers to heroes. It is turning DevOps and infrastructure engineers into heroes and turning them into actual, superpower team, kind of.
Interesting. I think it's quite empowering because, today with like a lot of companies thinking about cost cutting, cloud repatriation is one of the terms that is becoming popular, and people want more control over their costs and even probably control over performance, cost to performance ratio. And they're taking back their infrastructure. And I think VPC gives them that ability to do that. Wouldn't you say that?
Yeah, we see many cloud repatriation and hybrid cloud use cases with our customers, and which makes a lot of sense to me. Cloud is great for many organizations, for many use cases, but there are a lot of cases when cloud is not economically viable, especially for SaaS companies where they have revenue, they have cost, and their cost is like heavily based on their infrastructure cost. And having high cost in a public cloud, it's messing up their margins. So when companies are young, margins are probably not important because they are finding their product market fit, they are finding their target audience. That's totally fine. But when they grow further, margins are becoming important, and a great way to improve margins is to go hybrid. So basically take out data heavy applications, traffic heavy applications. So egress makes the big part of public cloud costs. So like taking that part into, bare metal cloud provider, take that parts into colocation provider, data center, somewhere else with a way lower cost structure. Now, way lower cost structure is typically 90% lower cost. And if like your cost is like 50% of your revenue in the public cloud, and when you reduce that 50% by 90%, you're going like very, very low. Like that's a significant impact on your business health, your unit economics. Now, remember, cloud is easy and data center is hard in terms of networking. And teams that are cloud native, they are not accustomed to running data centers. So big part of Netris's value and mission is to help these teams to treat their data center and their public cloud in very much similar way. So we turn their data center, their bare metal, their edge into kind of cloud-like self-serviceable network. Now you have VPC in your public cloud and you have VPC in your private cloud. Both look and feel the same. You don't need to have two different pipelines. You don't need to have like two different teams for two different infrastructures. The same team works with both infrastructures. And now your decision of which application works in what environment, public cloud versus private cloud, becomes a business decision. So organizations need to be able to like decide where they run their applications as a business decision, not a 6-month long IT project.
Interesting. So there are definitely those companies which already operate VPCs and they're quite familiar and they're looking for ways to optimize it and do it better. But there are probably quite a few listening here that I'm sure are thinking about VPC and they're very invested in the public cloud. And they're probably wondering, is VPC for me? And so if you can, what would you say to that group, the second group of people who are kind of on the fence about VPC? What would you say are some of the use cases for VPC, which maybe a lot of people don't think of, but is actually a really good use case? Could you give us some of those examples?
So when someone is using public cloud, they are already using VPC, right? There were some like older versions of public cloud would work without VPC. It was a little bit different model, but like today, when you're in public cloud, everything networking that you consume, that's part of VPC. So teams that are already using that model, they want to replicate the same model somewhere else, right? Because if one day, and it's actually business continuity kind of thing. It's strategically important for the company. If it's a cloud-born company, one day they will go hybrid. If it's a data center-born company and it is still using like traditional networking concepts and didn't embrace VPC yet, again, we're living in a kind of a time when going hybrid is just a matter of time. And even this data center-born companies without VPC, they will go hybrid. They will have public cloud deployment too. And no matter where you start in data center or in cloud native world, whenever you go hybrid, you're gonna end up with a situation where you have cloud native, self-operated, self-service VPC type of networking and traditional networking with like a bunch of F5s, with like a bunch of Cisco routers and like a team who's managing this manually and with all the consequences of being very slow to adopt and very slow to scale. Now, no matter where you start in data center or in public cloud, it is good to, even if you started in data center, it is good to like slowly go to the VPC model, because at least that will help you to adopt very high performance in terms of your engineering. Your engineers will be able to manage larger amounts of infrastructure. Your engineering team will collaborate internally better, because your developers, your DevOps engineers, your Kubernetes administrators will easily work with your network engineering team. So you're already winning with this. Besides, VPC brings a lot of VPC is all about abstraction, right? It is abstraction model, which means it's not attached to particular hardware. So as a byproduct of adopting VPC, you're becoming hardware vendor independent. And especially after a pandemic with the supply chain shortages, most companies notice that that's a critical business continuity requirement to be hardware independent. One vendor is out of stock, you cannot wait. You're hardware independent, you work with all kinds of vendors. And if we look under the hood of public cloud, Amazon, Google, they are exactly like that. They do not depend on particular hardware vendor, because they have VPC, they have lots of abstraction for entire infrastructure.
Interesting. When you say there's much better performance with VPC, could you quantify it or give us an example of maybe one of your customers or some organization that you're seeing go from public cloud to VPC, and what was the performance difference? Any example of that, right? Or from data center to VPC?
Performance-wise, it's usually cost and performance, because there's no like limitations on performance in the cloud or in the data center. In both situations, you can get whatever performance you requires, but it's matter of cost, right? If in AWS you need more cores, of course they are available. It's just you pay more, you got it. You need more traffic, you got it. In your own data center, because hardware very much progressed during last 5 to 10 years, and storage progress, so basically density of storage chips, of storage drives progressed, performance of CPUs progressed, and like 10 years ago, data center was more expensive than today because of hardware performance. With today's hardware, you think like you're using a lot of cores in public cloud, and you're like, oh, we have this large infrastructure, like you're paying a lot of money. Then you move to data center, and you're like one rack, or you're like half rack, and you're like, what? It's just handful of servers can perform like that? Yeah, because modern hardware is very performant. But as a business, you always need to think from financial perspective, which on average, I'm sharing the numbers, like average numbers across multiple customers. So they compare total cost of ownership, so like CapEx and OpEx for like 3 years. And that's usually 80% cheaper in data center compared to AWS if it's done right. Now another part of the performance is actually related to networking. So in traditional data centers, and especially 10 years ago, in order to get like high performance networking, you would need to have very expensive hardware like F5 firewalls, Cisco border routers, Juniper, routers and firewalls. Now with today's servers with today's CPUs that have a lot of offloading capabilities, with today's smart NICs that have some networking functions embedded in the hardware. If it's done right, you can replace high-cost, firewalls, F5 firewalls, Cisco routers with just a Linux machine. We're talking like $1 million of hardware being replaced by $15,000 server. 2 servers, okay, $13,000. With modern, open source software that is, leveraging DPDK, XDP, these modern libraries that are, communicating with the CPUs, using CPUs hardware capabilities, using smart NICs hardware capabilities, doing all these things right and being like purpose designed for data center use case, not generic thing, but like purpose designed for specific, let's say, purpose designed for VPC functions. You save a lot of money just on the equipment. That's, by the way, how Netris does, and that's how most our customers are. They run their network functions using just regular servers. That's it. No need for F5, no need for expensive Cisco routers. If they want to, they can. That's possible, but oftentimes for many customers it just doesn't make sense. And if we look under the hood of public cloud, AWS and Google Cloud, like their designs are somewhat publicly available through presentations of their architects, and their VPCs are running on servers with Linux, leveraging DPDK or XDP and smart NICs. We're doing the same, but for everyone else.
Yeah, with that, I think it's a good time to transition to talking about Netris. So can you tell us what does Netris do and what's unique about Netris?
Yeah, so Netris is Netris as company. We have software offering that also called Netris. So Netris software is designed to help everyone build and operate private and hybrid cloud networks. We don't touch compute, we don't touch storage, but we partner and collaborate with compute and storage companies. We're allies with these folks because networking is foundation. You in any environment, you first install network, and then you can install your compute and storage software. So you can think about Netris software as of like whatever the similar to software that is running under the hood of AWS, enabling AWS network engineers on the backend to operate AWS, and enabling AWS customers, Kubernetes operators, virtualization operators, DevOps engineers, enabling these people to consume the infrastructure. Whenever a customer needs to and wants to replicate a similar model in their either data center or in a colocation or with a bare metal cloud provider, they use Netris to bring that cloud-like user experience. We also have professional services where we are there for our customers to help them design and implement, maybe choose hardware. We can also help them integrate with their existing system. Maybe they are rolling out a Kubernetes cluster, maybe they need advice, maybe they want us to help roll out that Kubernetes cluster or virtualization cluster or storage cluster. So our professional services is also there to help them, as well as with involving some of our partners too.
Okay.
That's what Netris as company is all about. we're a team of passionate infrastructure experts. Most people on leadership and architecture are coming with extensive infrastructure background. Basically, people who build networks for a long time, people who operated Kubernetes. These cloud native integrations are a big part of our development, and people who develop, they've been, they are like deep experts of Kubernetes or like experts of cloud operations.
Yeah. The one follow-up question that I want to ask is, which are these partner organizations that help with storage and compute and all of these other pieces of VPC?
That's a great question. So we currently partner with few hardware companies. Hardware is always a big part of private cloud. So we partner with NVIDIA, with Dell, H-Core, NVIDIA. They have networking hardware. They're focused on AI, yes, but their networking hardware is just amazing. H-Core is another network hardware provider, so like standardized off-the-shelf kind of networking gear. Dell, they have both networking gear and servers. We also partner with bare metal cloud providers such as Equinix Metal, Phoenix Snap. So with all our partners, we have native integration. So our software natively works with their offering. That's important for our target audience because our mission is to bring this cloud experience, right? And that proper integration and thousands of tests being done between our engineers and partners engineers is critically important. We're also in the process of partnering with the platform providers, companies that provide Kubernetes platforms, that provide virtualization platforms, that provide kind of alternative container operating platforms. I cannot disclose the names right now because those are ongoing, but this is coming. So eventually, the entire cloud experience is going to be available, like full stack, like from your compute, your storage, your networking, everything will be available on any infrastructure out there in data center or in a few servers in your closet or maybe a couple racks in a cruise ship or in some factory. Anywhere, everything will look and feel just like the cloud. And that will be possible through collaboration of multiple companies. That's too big of a task for a single company to accomplish.
Sounds ambitious. We'd love to have you back to talk about that when it launches. But talking about the look and feel of cloud, I was wanting you to show our viewers what the Netris product looks and feels like. And even before that, you have a couple of slides to explain Netris before you give us a walkthrough.
Sure. So Netris is like the VPC, right? Netris is responsible for networking. So networking between compute and storage platforms and physical networking. So your Kubernetes cluster, your VMware cluster, your virtualization, whatever it is sort of consuming networking from Netris. And Netris kind of takes care of hardware networking, hardware configuration, like your switch configuration. If it's running in a bare metal cloud environment, Netris takes care of configuring bare metal cloud, provisioning behind the scenes. That's the idea. Now, there is this Netris controller thing that has a web console, which is where users interact with Netris. That web console also, that controller also has API and a Terraform provider. it's highly declarative. You don't need to be like, network expert to consume it. You just go there. It's kind of simple. Netris, give me a load balancer. Netris, give me this. I will show soon. So that's one aspect. We have this component called SoftGate, which is software that is running on a regular Linux machine that is leveraging DPDK and XDP functionalities, as well as using a lot of open source tools like free range routing, like WireGuard. And our job is to like connect and glue these open source components together behind the scenes dynamically for the customers. So customers, users, they only think in terms of controller. Netris, give me load balancer. Netris, let's drop this traffic. Let's enable that traffic. And Netris's algorithm will figure it out how to configure things behind the scenes for the user. Softgates are just Linux machines. This is the VPC gateway thing. And it replaces Cisco SRs, Juniper MXs, and F5s. Now, it's a Linux machine. You can scale it down to little deployment on, in your home office, or you can scale it up to like, monster machine with lots of CPU and RAM, like forwarding 100 gigs of traffic per every node. We have users that are, forwarding over 1 terabits per second of traffic for 100 millions of online users using multiple instances of SoftGate. And because it's software, it's Linux, right? You can load it on any platform. You can load it in a bare metal as a service provider like Equinix or PhoenixNAP, or in an EC2 instance in AWS and make AWS your another Netris region. Or if you're doing in a data center, it's a large infrastructure. In a data center, we have this switch fabric manager component that has the ability to operate switches, network switches, do the network switch configuration and the entire life cycle management to like operate network switch fabric for you. And again, entire communication happens through controller. So that was the introduction. And to show you, this is Netris controller dashboard. If you're in a data center situation, and if you are the network engineer person, you can see the switches, you can see your connections with your upstream providers, and you take care of network engineer personas concerns using Netris. But if you're DevOps engineer, if you're platforms engineer, if you're Kubernetes administrators, you're not using this part of the product. You're going to another part that is designed for your kind of situation. So you go into services, and here we have virtual networks. VNet is virtual network, and in this current virtual network is for my Kubernetes cluster. So I have 3 physical machines, as you can see here, and each physical machine shows 2 MAC addresses because there's 2 virtual machines running Kubernetes. I've got 6-node Kubernetes cluster here. And you can see that just like in public cloud, my Kubernetes nodes, they have private IP address, 192, 168, whatever. So how do I, as a DevOps engineer, access this Kubernetes cluster from outside? In traditional world, I would go to network engineer, would create a ticket for them, would wait them to configure NAT or something that would take forever. We cannot wait. We want things to happen immediately. In modern world, because this is cloud experience, you as a DevOps engineer, you go to services, load balancer. Think about elastic load balancer in public cloud. And you create a load balancer instance. You request this load balancer to be able to access your Kubernetes cluster. Now, here you can see I'm typing kubectl get svc. I can see that my Kubernetes cluster is accessible from my machine, from my home office, using the public IP address that load balancer provided me. And let's say next step, I'm going to deploy an application. See, I have a little application for Kubernetes that is using service of type of load balancer in order to expose application to the public internet. And in traditional data center, Cisco switches and Cisco routers, they don't know how to expose your Kubernetes to the rest of the world. You would need to come up with something. But with Netris, it's a different situation. Netris understands your Kubernetes. And when I'm typing kubectl apply podinfo YAML, and when I type kubectl get svc again, we will see it says external IP pending. And in the Netris web console, we can see that a new instance of load balancer has been automatically provisioned. It's being provisioned. So Netris has automatically identified the backend private IP addresses. The right private IP addresses has automatically configured health checks. And it's the health check is currently waiting on containers to start responding. Netris has also provided a public IP address, and we can see that back in our Kubernetes cluster, we can see that public IP address there. And if we try to access that, we can see that newly deployed application actually works. So I just deployed application in actual physical data center here in Santa Clara, self-servicing my network without asking network engineers for help. They are happy because they are heroes. They provided me with a network where I can self-service. I'm happy as a DevOps engineer. I'm doing my job better, and business is happy because in this world, you know, fast fish is eating slow fish, right? Every business wants to be fast.
Yeah, absolutely. Oh, that was a cool demo. Definitely something that people watching this probably should try for themselves. And it looks quite easy, but what are some other ways that Netris enables ease of use and even automation of the different networking operations that people have to do on a day-to-day basis for maintenance or during troubleshooting? What are some ways Netris makes life easy?
That's a that's a great question, and I like to think about automation twofolds. When people traditional say automation in data center, they would mean to like write a script, use Ansible and maybe write some Python scripts where scripts would go and like try to configure network equipment. So like that is very challenging because the engineers that are writing the scripts, they need to invest their entire time solving problems that are not unique for their business. Like, how do I configure IP address in this particular network switch CLI? That's not adding value to your business, and that's not unique to your business. Now, Netris takes care of all that generic automation. So you as a company, as an engineer, you don't think in terms of how you automate things that are generic for every business. How to configure, default gateway redundancy, or how you prevent loops, or how you configure your switches. These things just happen automatically. You don't even have like input on that. Netris will do whatever Netris algorithm thinks is right for you. But there is part of automation that is very unique to your company, right? So for example, maybe when there are a lot of signups for your application, maybe you need to expand your Kubernetes cluster. Maybe you need to, do something. Maybe you need to move loads from here to there. Maybe you're launching more machines and network needs to follow all these things, right? It's not just you automate your computer Kubernetes. No, the physical network needs to be aware of this too. And in public cloud, that's easy because it's declarative. You may use their API or Terraform or whatever is your favorite infrastructure as a code technology. That is not available in traditional networking, but it is available with Netris because Netris is built around that concept. Generic things, Netris automates the way Netris engineers feel is the great way of doing this. And we do rigorous testing with like 10,000s of tests on every aspect of built-in automation. Your business, your automation that is unique to your business, we give you right tools, right APIs, so you can easily automate. So invest your time of your brilliant engineers doing things that are unique for your business. This is how engineers will be the most appreciated, and it will be most beneficial for their business.
Awesome. Sounds really exciting. We're almost out of time, but I wanted to just ask you lastly about, as we look ahead to the future of networking, and you kind of, I think, gave us a hint of what's coming as well when you spoke about end-to-end, run, your VPC anywhere. But anyway, I'm teasing you a bit on this, but as you look ahead, in the space of networking and VPCs, what excites you the most? What are the possibilities you see? What are the opportunities that you're most excited about?
So, public cloud kind of showed the way where all the development in infrastructure space is going, and I think that future of infrastructure will be in a way that applications will be true champions. So everything will be around application. There's not, from engineer perspective, there's no gonna be, how do I make this application to work in this or that environment? Environments will be smart enough, will be interconnected, integrated between each other, and running your workload in Amazon, running your workload in Google Cloud, or running your workload in the closet, running your workload in physical data center on 1,000 machines or one machine, will kind of look and feel the same from practitioners' perspective, and DevOps engineers, practitioners will be able to fully focus on things that are unique for their business application part. This is interesting and exciting for infrastructure folks because some people need to build all that infrastructure. Our job is to provide the tools, but there will be all kinds of new vertical cloud providers, new infrastructure providers, and our technology and all kinds of integrations that we're working with our partners will be enabling this kind of vertical cloud and kind of cloud experience anywhere situations for any kinds of hardware in the world, because this world needs a lot of infrastructure. We will only be adding more and more infrastructures, and that's amazing because we need a lot of applications.
Yeah, wow. That definitely sounds exciting. Before you go, Alex, we have a couple of questions to get to know you a little more. So I want to ask you first, what would your alternate career path be if not for your job in tech?
if so, like without Netris, if I didn't.
I mean, yeah, if you were not a tech guy, a totally, completely different career.
Oh, good question. If I wasn't into tech, I don't know, maybe music. I love music, and and I
Do you
like
play any music?
and I love flying. I don't know. Maybe I would open a flying nightclub. I don't know.
Combine the two. That's neat.
Yeah.
That's high. Um, so yeah, well, the next question for you. So yeah, it's like CEO, you wear multiple hats. I'm sure being CEO itself, there's a lot of learning about just how to lead a company and all of that. But what's something that you found out after becoming a CEO that you didn't know before about the role? I mean,
Like
what it
one thing,
involves and stuff.
one thing, or
Or anything in like a minute. Any number of things in a minute.
um, I think there's lot of learnings indeed. I think the few like the top things, like your team is everything. Just being, hiring people that are passionate about doing. Hiring people that are passionate about your mission is kind of key, and just trusting them, trusting their gut, and like guiding them. That's kind of key important thing. And also listening to customers is incredibly important, because oftentimes you may think that you're doing the right thing, but like questioning your thought is very important. Don't just trust your gut. Trust your gut, yes, but also kind of apply like scientific approach. Go to talk to customers, see if this makes sense to them, if that makes sense to them. Ask them if they will pay for that. Like that's because some people may say you're doing amazing thing, and when you say, will you pay for that, and if they are like, oh no, probably not, then maybe that wasn't a true feedback. But when someone is ready to pay, that's like very strong signal that you're into something. Now figure it out if it will scale. Kind of top things, but there's a lot of learning, like being open-minded and like being able to like admit your mistakes and try to do better. That's also critically important, that I've learned sort of being in this role.
Wow, that's a lot of really good advice and good points you made there. Yeah, I can definitely tell that you have a lot of learnings that you keep track of and you make a record of. What's
Every day.
one what's one software tool or product that you think is very elegantly built?
There's elegantly built. So I mean, Linux kernel is critically important, but there's like, if you're looking into the code, some things are extremely elegant and some things are not as much. So, but that's amazing piece of technology. Kubernetes, of course, there's a lot of concepts, a lot of new concepts that I guess world learned through Kubernetes. I'm not saying that Kubernetes is replacing everything. No, other technologies have their own place too, right? Kubernetes is obviously big, and to me, Kubernetes is just like Linux kernel. It will be around forever. But you mentioned elegant and learning, so like there's really a lot of nuances in terms of how do you think about infrastructure architecture that it was inspiring to learn and see from Kubernetes' life cycle.
Interesting. Now, complete the sentence. I can spend hours doing.
I can spend what?
I can spend hours doing.
Oh, reading. Yeah, I can spend hours reading books. I like reading.
Yeah, I see some books behind you there. Do you have a favorite that comes to the top of your mind?
Oh, I love all of them. All these
Okay.
books are amazing. And being a person coming from technical background and starting with entrepreneurship, like learning from books, also from my mentors and from my experience, but a lot from books. That was like big part of my path.
Really neat. Last question for you, Alex, is if you could hang out with anyone in the world, living or dead, uh, for a whole day, who would that person be?
My family,
Okay.
yeah, my wife and my daughter.
All right. All right. Well, I asked someone else this question just on the previous episode. I think they also gave me the same answer. So I think I should change my question.
So this is consistent.
Yeah, but no, I think that yeah, it is quite true, and I think all of us need more time with family. There's never enough time.
Yeah, yeah, exactly.
Yeah. On that note, yeah, it'll come to the end of our conversation. Thank you so much, Alex, for joining us. It was a pleasure chatting with you about all things networking and VPC. I think I'm a fan of what you guys are doing at Netris, and I can definitely see the passion that comes through in the way you describe what you're doing. So great job with the product. All the best. And as you have the new features that are coming in the next few weeks or months, definitely let us know so that you can come back and talk to us about it soon. Thank you so
Awesome.
much.
Thank you so much, Twain. It was a pleasure being on this conversation.
Right. And thanks to all of our viewers and listeners. We hope you enjoyed this conversation about networking. Do tune in again next week for another one like this. Bye bye.